So in section 1D, we started talking about conditional percentages and how different groups can look different based on the size of that group and how it can be deceiving. So for example, it starts conditional percentages in 2D that we are going to explore more deeply now. It answers the questions like this. When we take a look at the sports car two-way table, it shows that 45 women chose sports car as their favorite car, while 39 chose sports car. So with this information, answer the question, in this survey, do more women or more men prefer sports car? It looks like more women. There are more women that prefer the sports car. 45 is higher than 39. The frequency of the number of women that choose sports car is higher. However, there's simply more women in the study. So when we split up our men and women into different rooms, the room that had females had under 180 people in the room, whereas the room with males had only 60 people in the room. The room with 180 people just had more people in it. So that's why that number of 45 happens to be higher than 39. There's just more people to choose from. The room's already crowded. But the ratio, the proportion of women that are raising their hand for choosing the sports car may be lower, even though the frequency is higher. So that's why we start looking at conditional percentages in section 2D. So it gives us a more meaningful answer about one group from a two-way table. A relative frequency, not just frequency, but it's the frequency relative to the size of the group that we're pulling from. So let's answer the question, what percentage of women preferred a sports car? You may remember my previous recording when I said when you see that word of, that's going to tell you what's in the denominator. The denominator is percentage of what? Of, and the answer here is women. How of women? So the number of women or females is 180. So that gives us 180 in that. So the keyword of percentage of, and whatever comes after the of is representing what's in the denominator. So here we have what percentage of women, and the women is 180. So that's our denominator. And then for the numerator, I'm looking at, of these women, I'm already in the room that has the females. What proportion of them, or what number of them, preferred a sports car? So then I go to the female row, and in that row, what's the frequency of the people that chose sports car? And that answer is 45. So we have 45 of the women, 45 of the 180 women chose a sports car. So what percentage of women preferred a sports car? First, we highlight the row or column of the group we are interested in. That's your condition. So the condition is, which room are we in? If we split our group into men and women, or males and females, and that's the condition. They go to the room based on that condition. So now we're just looking at the condition of female. So we're in the room where all the females are. Oops, sorry, jumped ahead a little. Now we're looking at, the next thing we're looking at is, of this row, in this room with the 180 females, how many of them preferred a sports car? 45. So there's 45 that raised their hand for sports car out of 180 total people in the room. So that gives us our conditional frequency is 45, and the total numbers of females is 180. So the conditional proportion is the amount of people that raise their hand in the room and over the total number of people in the room. So our conditional percentage is that times 100, which gives us 25%. So 3 steps in a conditional percentage. Your denominator is not going to be that grand total. A conditional percentage the denominator is going to be either the column total or the row total. It's going to be only the row or the column that fits that condition. So the first step is highlight that condition. Here our condition is females. Then our conditional frequency is 45 and the total number of females is 180. So what percentage of the women preferred a sports car? If we look, so I want to go over some equivalent. So before I said the word of tells me that the denominator is going to be of all the women, the number of women. There's some other ways to look for the denominator too. Some other keywords that mean the denominator. If we only look at the females, what percentage of people prefer sports cars given that given that the people are females? So these are our keywords that show that our denominator is conditional based on the condition that they're female. When we see the word of followed by the group of people when there's no given in it. Or if I see if, that means we have a condition. What's the condition? If we're looking only at the females, so that means my total, the denominator, is going to be just the number of females. And last keyword is that given. These three, the word given and the word if tell me that this is a conditional. So the group of people I'm looking at is going to be a smaller group. Looking at only the females, or given the people are females, means an of the woman with no other conditional words in there, means that the denominator is going to be the number of women or females. And then the last one is out of the women. So out of the women means the denominator is the number of women. So take a second at this slide and look at these 4 different ways of telling you that the denominator is going to be the number of women. These are 4 different ways to list the condition that the denominator is the number of women, not the grand total. So now we can answer that question. Do more women prefer sports cars than men? So now we're going to look at the percentage, or the conditional percentage, of the women who prefer sports cars and the men. Not just the frequency, but the relative frequency, or the conditional percentage. So we know 25% of the women prefer sports car. We just calculated that by doing 45 over 180. And now we need to find, what's the other information we need to know? Is what percentage of the men preferred a sports car. So we're going to do that same process we did for the women, only we're going to do it for the men this time. So first step is highlight the row or column of the group you are interested in. This time it's men. That percent of men means we're looking for only the men, and the number of total men goes in the denominator. That's that column right there. That row right there. And in that column, that row, we're looking for which ones of them had preferred a sports car. So on that row of 60 men, how many of them chose sports car? That's that 39 right there. So we have 39 out of 60 preferred a sports car. The conditional frequency is 39. Oops, that should say males. Total is only the males, so that's 60 people. So the conditional proportion is 39 over 60, which gives us 0.65. Multiply that by 100 to get 65%. And there's our 3 steps. Find the conditional frequency and the total. And then divide to get the proportion. And then multiply by 100 to get the percent. So now we have 25% of women preferred a sports car. 65% of men preferred a sports car. This is a more honest representation of the results. So do you think there could be a relationship between gender and the preference for a sports car. Well, you may recall from a previous section when we did 1D that we got percentage ratio, and that can tell us that there's a relationship. Is this difference between 25 to 65 significant? If it's significant, then yes, there is a relationship. Is it significant? So we take the higher percentage, which is 65, over the lower percentage, which is 25, and when we divide, we get 2.6. And if you remember that rule, if the percent ratio is 2 or greater, then that does show a significant difference. And if there is a significant difference, that means that these two variables of gender and car preference does have a relationship. They do seem to be related because the percent ratio is greater than 0 and greater than 2. Now here's the question of the unit. Does this mean that being a male causes a person to like a sports car? And hopefully you remember that first sentence from Unit 1, the first page of Unit 2. No, the relationship does not prove causation. Correlation does not prove causation. Yes, there is a correlation between gender and car preference, but it's not necessarily the cause. We cannot make any assumptions about that. We can only calculate numbers and see what's corresponding, but with statistics, we cannot determine cause. So here's a quick summary of those relationships. When values, conditional proportions, are significantly different, the percentage ratio is greater than 2. That means there is a relationship. So when that percentage ratio shows a significant difference, means the groups have a different percentage, different proportions. That shows that there's a correlation between the two variables we're looking at. When the conditional proportions are very close, such as if we found out that 50% of the women and 50% of the men both liked sports cars, that would show there's no relationship. It doesn't matter what the gender you are to see what kind of car you like. So relationship or correlation does not prove causation is the summary. The other summary for this recording is conditional percentages uses the column or the row total, unlike from 2C where we saw marginal and joint percentages using the grand total.